Good morning. It's Tulani Kelvin the tutor. We are proceeding with our lesson. Today I'm starting a new chapter, which is chapter 8. I'm going to focus on the quantitative aspects of chemical change. It's our topic for today. So under this chapter we are going to focus on the gases and solutions, the stoichiometry calculations, the volume, relationship in gaseous reaction, and the chapter summary. I'm not going to to do it with you. You understand? I'm having the symptoms of flu today, guys, so that's why my voice is like this. You understand? So I guess I'm going to be fine as time goes by because of this change of season. Soon enough, we are going to summer since it's July. Yeah, I just think it's change of season. Okay, starting off, they say whenever we look in real life, we see that the importance of mixing things, the importance of mixing things in precise quantities. Cooking and baking, the medicine you take when you're sick, like me, the medicine that I take because of I'm affected by flu. The product that you buy, all of this rely on the ingredients being mixed in a specific amount. You know, everything, yeah, the cakes that we eat, you know, is a combination of different things there, and then they combine them to form something else. You understand? And even the amount of product form realized on how much of each ingredient is used. In this chapter, we will look at some of the quantities and how they can be calculated. Well, I don't like to just jump into the chapter, but I prefer to read the introduction first so that I can know um the concept or the basics that I of the particular chapter. You understand? Because of it's very important. I feel like it's very important. I don't know about others, but I recommend that you should every time study the introduction. You understand? They say in grade 10 we learned about the writing chemical equation and about the information that can be obtained from the balanced equation. In this chapter do we are going to explore this concept further and learn more about these gases, solutions, and reactions. We will explore the concept theoretically yield in a greater detail and learn about limiting reagents. So the key mathematics concept that you should know: the ratio, the proportions, physical sciences, grade 10, the science scale. You must know the equations, mathematics, grade 10, equations, inequalities, units, and unit conversions. You must know how to convert. You understand? So that's why I say it's important for you to study the introduction before you can just jump into the conclusion. You can just jump into the chapter. You understand? So moving forward, 8.1 there is gases and solutions. So we will begin by taking a closer look at the gases and solutions and work out how to solve these problems relating to them. So we have a molar volume of a gas. The first thing that you must know the standard temperature pressure, STP. You must know standard temperature pressure. You must know that you must know the constant of STP. You understand, which is 22.4 decimeter cubed. So I'm going to just simplify it for you. I'm not going to take all of this notes that you are given in this textbook. I'm just going to jump into the the calculation so that I can show you how we apply these things. You understand? All right, let's get to the board so that we can try to wrap this thing out here. So STP, which is the standard temperature pressure, you must know that 1 mole of a gas at STP, 1 mole of a gas at STP is 22.4 decimeter cube. This one is the basic that you must know about the STP. Understand the standard temperature pressure. You must know that 1 mole of a gas at STP is equal to 22.4 decimeter cube. So let me just give you an example. You can be given a question, or I don't know, anything, equation. Let me put it as a question, and they say, what is the volume of 2.3 moles of hydrogen gas at standard temperature pressure? Let me just write this question for you. There we go. Yeah, the question says, what is the volume of 2.3 moles of hydrogen gas at STP? So we know that 1 mole of a gas at STP. Oops, I'm sorry here. What happened? We know that 1 mole of a gas at STP is equal to 22.4 decimeter cube. So in this question, they are asking us what is the volume of 2.3 moles of a hydrogen gas at STP. So this is simple, you understand. If we were to calculate the volume here, what are we going to do? We know that 1 mole of a gas at STP is 22.4. So just have to come here, take the number of moles, is 2.3 times 22.4, and then you can automatically punch this on your calculator. You will get your volume as 51.52 decimeter cubes. So make sure every time you write your units on your final answer, you understand, because of they say if you won't put your or you don't write your SI units there, therefore you won't get a mark. You understand? They will penalize you for that. So make sure that you write that. So standard temperature pressure, this is simple, guys. You understand? All you have to know is that 1 mole of a gas at standard temperature is equal to 22.4 decimeter cubes. And then when you know this, even if they can ask you a question, they can give you what is the volume of, maybe they give you 5 moles here. They give you 5 moles of any atom, element, anything. They say silver or something else, you understand, copper. You just have to take the number of moles multiplied by the standard temperature there, and then therefore everything is going to be correct, and then write your final answer there. So moving forward, we are going to go for reaction and gases. So that was the molar volume of a gas at standard temperature. So now we are moving forward to the reaction and gases. So under the reaction and gases, you know how things are. As time goes by, the standard is also increasing. Understand? So now I'm introducing a new formula where you have VA is equal to A there over B and V of B. So The VA is a volume, is a volume of compound A, and then B automatically is for compound B, volume of volume of compound B. I'm not writing that in full. I guess you already know that. So when we move to this one is the stoichiometric coefficient of A. Stoichiometry coefficient of A. Stoichiometric coefficient let me just save time. Coefficient of A, compound A, and then automatically this is going to be the stoichiometric coefficient of B, since it's B, you understand? So you must know your formulas, you must know your formulas, how are they working there. You must know everything about the formula so that you can know, you will know what to substitute and where to substitute it. So moving forward here, we are going to, I'm just going to do an example for you applying this formula. So in this case, I was given 2 hydrogen. Okay, let me just write it. 2 hydrogen gas. I was given this formula there, or the equation there. So what you must know about this concept is that you must always make sure that your formula is balanced. You understand? You must balance the equation. You must make sure that you balance the equation there, because of if you don't balance the equation, therefore your answer is going to be wrong. I guess in grade 10 you did learn how to balance the equation. That's why I did the introduction first there, so that I can know the concept of this chapter. You understand? So balancing here is required, you understand, so that you can get the correct answers. So we're also given a statement that they say if 3 decimeter cubes of oxygen gas is used, what volume of water is produced? You understand? So they want the volume of water. If hydrogen and oxygen, you know that hydrogen and oxygen, when they react, they give us they form water. You understand? So in order for us to calculate the volume of water after this reaction, so we are just going to say VA. We apply the formula VA A over B VB. So you must collect your data. I can say that you must collect your data, but this one is simple, you understand? So since we are looking for the volume of water, I will just say V of H2O. So you still remember this is the stoichiometric coefficient of compound A. So which one is compound A? Is this one, you understand, the hydrogen gas. So I'm just going to substitute 2 here, which is this is the stoichiometric the stoichiometric coefficient of A there, and then for compound B automatically is going to be 1, because of we have nothing there. Basically we have 1. The problem is that we can't write 1 there, you understand? So just going to say 1 over here. So let's go to our statement. If 3 decimeter cubes of oxygen gas, so we are given the volume of oxygen there, you understand? and we can simply substitute the volume there, and my answer is going to be 6 decimeter cube. 6 decimeter cube. So these things are not that much difficult. If you practice them, you give yourself time so that you can, understand these things. Yeah, you will understand them. You understand? It's easy if you practice, but difficult if you don't practice. So here is the next question. They say, what volume of oxygen at STP, standard temperature pressure, is needed for the volume to complete for the what am I saying actually? I think what volume of oxygen at STP is needed for the complete combustion of 3.3 decimeter cube of propane. So we are given the formula there. So sometimes they're not going to give you the equation, you understand? So you must know these things, guys. You must know their general equation, the general name, so that even if they just give you the statement, you will be able to write that equation there and then be able to balance it, you understand? So you have to balance this equation here. So I'm not going to basically, this is not the lesson where I teach people how to balance the equation, you understand? And then if you need a lesson where I show you the simplest way on how to balance the equation, you can just comment on the video. Yeah, just comment on the video, and then I will specially make a video for where I focus on balancing the equation, you understand? So now this is a balanced equation there. I've just added 5 and 3 here and 4 there. If you know how to balance the equation, you will see that. If you don't know, just comment on the video, tell me that you don't know how to balance the equation, and then I will provide you with the lesson, the special lesson for balancing the equation. Because of, remember in the first introduction of this lesson, they said that this is the balancing is something that you did in grade 10, you understand? So yeah, basically balancing is simple. If you have 3 carbons in this side, you must also have 3 carbons that side, you understand? If you have let's say you are having 10 oxygens this side, you must also have 10 that side. So that is what is called balancing of equations, you understand? 4 times, let's say 4 times 2 is going to be 8, meaning that I'm having the 8 hydrogens there. I also have 8 this side, understand? So you must, that's how we balance, basically, just to give you a hint, you understand? So they want what volume of oxygen at STP is needed for the complete combustion of 3.3 decimeter propane. So we are given the equation there, and then we did balance it correctly. So, and then we should just determine the volume of oxygen. Let me just say the volume of oxygen, guys. So you already know this formula is for the second time I'm using it, and then I did explain it. So I'm just going to substitute the stoichiometric coefficient of compound A, and then I will also do the same for compound B. So for compound A is 5 and compound B is 1. So in this case, I took this one to be my compound A and then the other one to be compound B, and then let me substitute the volume for oxygen there. So it's 3.3, and your answer is going to be 16.5 decimeter cubed. 16.5 decimeter cubed. Yeah, they are not that much difficult, they are not that much difficult. All you have to do is to practice, study is the key to understanding everything. So let me just give you a hint again here. Let me give you a hint. 1 decimeter cubed is equal to 1000 milliliters, and is also equal to 1000 centimeter cubed. So let's say suppose you are given 3 centimeter cubed, and you have to convert it to decimeter cubed. This this way is where when we convert. So you will just divide this by 1000. You understand? Divide this by 1000. Sorry. You will divide this. What the fuck am I doing? Sorry about the fuck. Divide this by 1000 there, and then you will get your answer as decimeter cubed there. You understand? So you must know how to convert, because of in some cases you will be given the your volume in any units, and then you know that we work with the decimeter cubes. So you must make sure that you understand that. You understand? So moving forward, let's just proceed to the next concept. Concept. So when we proceed with our lesson, we go to solutions. Let's just study this, the introduction. They say in grade 10 you learned how to calculate the molar concentration of a solution. These people, if you didn't study your grade 10 well, it's going to be difficult. So guys, just take your current class serious, you understand? Because of even now, if you don't study your grade 11, if you don't take it serious, let me put it in that way, therefore you're going to face challenges when you get to grade 12, you understand? So they say the molar concentration of a solution is the number of moles of a solid per liter of solvent. Therefore that's the SI unit for that. And this is also, let me just highlight this for you so that you can, let me use the color green. This is more commonly given as a mole of a solid per cubic decimeter of a solution. Okay, this is given like this. So to calculate the concentration, we use this formula: C is equals to N over V. C, which is the molar concentration, and then N is the number of moles. V is the volume of the solution. Calculating the molar concentration is useful to determine how much solute we need to add to a given volume of a solvent in order to make a standard solution. A standard solution is a solution in which the concentration is known to a higher degree of precious oh, I'm saying pression. So I don't know why I'm talking about precious. Maybe I miss precious. Who knows? So moving forward to this concentration, it's not difficult, it's not difficult. So let's just look at this question here. Okay, let's just look at this question here. They say how much sodium chloride in grams will one need to prepare 500 centimeter cube of a standard solution with a concentration of 1 decimeter cube. I'm not no, 0.01 mole per decimeter cube. I'm sorry about that. Okay, this is amazing. I can write here. I didn't know. This is the first time I'm trying this. So look at this statement. We are given the volume. You understand? We are given the volume. Oops. We are given the volume. We are given the volume. We are also given the concentration. They say how much sodium chloride we need to prepare a standard temperature of concentration. So first of all, let me just go to the board so that I can explain this much better. So we are given the volume as 500 centimeter cube. So you still remember I told you to convert this to decimeter cube. Decimeter cube. So this is easy. Divided by 1000. You remember, divide this by 1000, and your answer is going to be 0.5 decimeter cubed. And then therefore we also have the concentration. We also have the concentration. This is data. Let me just say data, or given data. You can just call it given data or data. So we also have the concentration. Concentration is 0.01 mole per decimeter cube. So we can use this formula where concentration is equal to the number of moles over the volume. The number of moles over the volume, you understand? So the concentration is 0.01. We can substitute that, and then we can also substitute our volume, which is 0.5. So if you punch this on your calculator, you will get the number of moles as 0.005 moles. So from here, what you can do you still remember that formula of N is equals to the small m over the big M. So with this formula, you can automatically calculate the mass of sodium chloride, you understand? So if you want to calculate the mass of sodium chloride, what you are going to do, you just substitute what you have on this equation. We have the number of moles, which is 0.005, and we also have we don't have the mass which we are looking for, and then we also have the molar mass. We can calculate the molar mass. The molar mass in this case is going to be, okay, let me just do it like this. Let me not skip too much. Okay. So in order for us to calculate the molar mass of a this is too much. Let me put it that one. In order for us to calculate the molar mass of sodium chloride, you remember the sodium chloride, NaCl. This is sodium chloride. So we just come here on our periodic table. We will take the atomic mass of each element here. So for sodium is 23, as you can see right over here. And then let's come for chlorine is 35 there, and it's going to be 23. This is the big M, the molar mass. Understand? Use the atomic mass there. 23 plus 35.5 is going to give you something like 58.5. And then let's just substitute our molar mass there. Our molar mass is going to give us 58.5. You did so how we calculated that, and then what you have to do, you can cross multiply here. You understand? This will multiply with that, and this will multiply with that. Or what you can do, you can multiply both sides by 58.5, 58.5. 58.5 will cancel with 58.5, and then it's mathematics, you know. So our m here is going to give us 0.29 grams, 0.29 grams of sodium chloride. So that was our question. That was our question. So let's proceed. They say we will now look at another use of concentration, in which is a titration calculation. So this is a technique of determining the concentration of an unknown solution. This concept, it can be done using many different types of reaction. Base reaction and a redox reaction are both commonly used for titration calculations. So they say in grade 10 you did a sample acid-base titration. Now we will look at how to calculate the concentration of an unknown solution using an acid-base titration. So we can reduce the number of calculations that we have to do in this titration concentration. So let's just look at what they have here for us. So this is the general formula for this concept of concentration. And then they also say, yeah, we are going to use this formula. The A and B are the stoichiometric coefficient of compound A and B respectively. So we already know that. I guess so. I believe so. You understand? Because of this, this is just as for of that previous equation there. So here we were given an example. So I will just read the statement here and then try to explain this on the board there. So they say we are given the equation where the equation is this is the equation there. We are given NOH blah 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 until, so I believe you can see this, and they say 25 centimeter cube of a 0.2 mole decimeter cube hydrochloric acid solution was piped into a conical flask and titrated with a solution with sodium hydroxide. It was found that 15 centimeter cubed of sodium hydroxide was needed to neutralize the acid. Calculate the concentration of sodium hydroxide. So here we should calculate the concentration of the concentration of sodium hydroxide. Let me just go to the board so that I can write my data. So if you see that the statement is complicated, or you don't understand, so it's going to be or is difficult for you, just extract your data so that things can be easy for you, so that you can see what you are given, what you are not given, what do you need, you understand. So we have 15 centimeter cubed of the compound there, and then we also have the volume of compound B. Let me call it compound B, HCl there, which is 25 centimeter cubed. So you can see that these units, we should convert them. And then we also have the concentration for HCl. The concentration for HCl is going to be 0.2 mole decimeter cube. So now we can see that we are given Okay, let me just rewrite the equation here. Let me rewrite the equation. NaOH. This is AQ aqueous is aqueous HCl. They form water. These two, they form water and salt. Yeah, water and salt. It's science, guys. Physical science. Okay, we have we are having everything from here, so we can just simply copy our equation on our board. It's going to be concentration of compound A multiplied by the volume of compound B, and equal to the ratio of the concentration of compound B over the multiplied by the blah blah stuff there. So moving forward, I'm just going to substitute what I have here. So let me start with the easiest one. So let me just say I have 0.2 okay, now what am I doing here? 0.2, which is the concentration of hydrochloric acid there, and then I should convert this to decimeter cubes. So I'm just going to divide it by 100. It's going to give me 0.025 decimeter cubed. This is 5. I hate this eraser because of it erases something that I don't want to erase. Okay, 0.025 there, and then if I convert this one, it's going to give me 0.015 is decimeter cubed, right? Don't forget that. Okay, now I can substitute my values since they are all converted. It's going to be 0.025 and divided by, I'm just going to divide it by 1 since there's nothing on my equation there. The stoichiometric coefficient is 1, you understand? So I'm just going to substitute 1 there, and then let me just come for the concentration of NaOH is what we are looking for, and let me multiply it by 0.0.1, 0.015. This is the concentration of this. So this is how you should you should calculate for this, and then automatically you just apply math there. Obviously this will multiply with that. We are going to have the concentration of NaOH there multiplied by 0.015 divided by 1, and then you just have to divide this by this, and then therefore you're going to get your answer there. I believe you understand me there. So the concentration here is going to be 0.33 mole per decimeter cube. Yeah, this lesson is it's too much. It's too much for me. I feel tired now. I feel tired. I hope I'm wrapping it out now. Okay, let's proceed with the lesson. I guess this is the last part of the lesson, the stoichiometric calculation. So in grade 10, you learned how to write a balanced chemical equation. Like I said, if you don't understand how, you don't know how to write a balanced chemical equation, just comment there or on our video, or you can just comment on our on our Facebook page. There is tutors. You can just leave a comment there, and then I will provide you with the special video where I show you how to balance the equation. Video of maybe 20 minutes. 20 minutes is a lot. 10 minutes, I guess it will do. Okay. They say you learned how to write a balanced chemical equation and start looking at stoichiometric calculations. By knowing the ratio of a substance in a reaction, it is possible to use stoichiometry to calculate the amount of either reactants or products that are involved in the reaction. The following figure highlights relation the relation between the balanced equation and the number of moles. So here we are given the something like a stoichiometric flow diagram there in figure 8.1, and then we can see we have the mass. We can use the formula here. We can use this formula, and the concentration. We also have the volume. The volume, which is we use it at standard temperature, the way N is the number of moles, and these are the reactants of moles. The balanced equation, the products, same story with the products, you understand? So they say in grade 10 we explored some of the concept of stoichiometry. We looked at how to calculate the number of moles of a substance and how to find the molar mass. We also looked at how to find the molecular and the empirical formula of a substance. And now we will explore more of this concept, such as limiting reagents, percentage purity, and percentage yield. So these are the concepts that we are going to focus on: limiting reagent, the percentage purity, and the percentage yield. So those are the things that we focus on, the concept that we are going to focus on. So the limiting reagent. So here you are given a hint, I guess, is the definition, is the experiment of limiting reagent. But they say what is a limiting reagent. For this activity, you will need a A4 sheet for blah 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 yellow what. I'm not going to. I'm just skipping this that experiment there. Okay, let me just get straight to the definition. A limiting reagent is a reagent that is completely used up in a chemical reaction. Is a reagent that is completely used up in a chemical reaction. So if you like this definition, you can just take it for yourself so that you can just take it for yourself so that you can write the correct definition on your exam, test, anything. And the definition, another definition, excess reagent. An excess reagent is a reagent that is not completely used up in a chemical reaction. So if you know the limiting reagent, you can easily understand the the excess reagent there. So let's just look at some work examples here. Okay, so here's the question. It says sulfuric acid. You're given the compound there, or the equation. So sulfuric acid reacts with ammonium to produce the fertilizer ammonium sulfate according to the following equation. and then we are given that equation. They say the maximum mass of ammonium sulfate can be obtained from is 2 kg of sulfuric acid and 1 kg of ammonia. So they want, but they say what is the maximum mass of ammonium sulfate? They want the maximum mass of this ammonium sulfate. So let's just go to the board so that we can just try to elaborate this. Yeah, this is going to be kind of tricky, I can say so, or maybe it's going to be complicated because of, yeah, I can just put it in that way, complicated. Let me just copy the question on the board. So there is the equation, and they say what is the maximum mass of ammonium sulfate? The maximum mass of aluminum sulfate that can be obtained from, we have 2 kg of sulfuric acid. So the 2 kg of sulfuric acid, we have 2 kg of this. Let me just put it in this way, 2 kg of this, and then we have the 1 kg of ammonium again, 1 kg of ammonium. So since, well, they want the mass of the maximum mass of ammonium sulfate, so first thing that we can do, we should determine the moles of these two compounds that I have here. So let me just say what I will do, I will just convert this to grams. Since we are working with grams, it's going to give me 2000. I just multiply this by 1000, multiply it by 1000. In this case we don't divide, we multiply it by 1000 is 2000 grams, and then here I'm going to have 1000 grams. Okay, so moving forward, the formula for moles. I'm going to have the small m there, which is for the mass, and then the big M is for the molar mass. So here I'm having the 2000, and I showed you how to calculate the molar mass. So my molar mass, I did calculate it, is 98, and then and the number of moles here, I get it as 20.4. So let's just proceed again and calculate the number of moles for ammonium there. So is N is equal to let me just say is 1000 all over the molar mass of N there is 17. I got 17, and then I get my moles as, oh, don't forget your SI unit mole is 58.8 mole. Don't forget your SI unit, this is important. So this is the first step, you understand, that you must do. This is the first step, and what you are going to do now, we are going to do the ratio. You understand? We are going to do the ratios. So let me just use a different marker. So I will just do a ratio between this and this. Understand? So the ratio between this is going to be 1:2, or you can say 2:1, either way. You understand? and I'm going to do the ratio again for this and the products there. So my second ratio, let me use this one and this one. So the ratio here, look at the number of moles here is nothing, it's 1, you understand, and here is also 1, so the ratio here is going to be 1:1, you understand, 1:1. So since I showed you how to do the ratio, so I will determine the number of moles, you understand, the number of moles using these ratios, you understand. So let me just show you how we handle this kind of questions. Let me start with the blue marker. So let me start with the blue marker so that I cannot, let me just, so my formula is going to be like n of let me say I determine the number of moles of this n, oops, what am I doing, NH 4 2 SO4, and the number of moles, this is the number of moles of this equation, therefore is equal to the number of moles of NH3 so for the NH3 there, you multiply it with A and B. Let me just use A and B. The coefficient of the stoichiometric compound. Do you still remember that? I guess so. So now what I'm going to do, I'm just going to take the I'm sorry, I think I'm making a mistake here. Let me just check my things properly. Yeah, now I did fix my things, because of the ratio is like the first compound here with the products, and then this one with that one. That's why it's 1:1, 2:1. You understand? Sorry about that. I'm sorry. So moving forward, I'm just going to take the number of moles for this for ammonium, you understand, the one I calculated there. So what I'm going to do, I'm just going to substitute them here. Is going to be 58.8, so multiplied by the ratio there. The ratio there is going to be my ratio is going to be 1/2, and then the answer is giving me 29.4 moles. 29.4 moles. And then we move on to the next, to the green one. So same thing that you do here, N and H. I think I'm going to just cut this video here on this limiting reagent, and then I will cover the next topics on the next video. And I'm aware that I didn't finish up the I don't have enough space. I didn't do on the ideal gases, I didn't do Charles' law, so I will also provide the video for that, guys. My apologies. Just that we have been facing load shedding worldwide, so the whole South Africa was under load shedding. It was a big problem, you understand, so we couldn't do anything because of the load shedding. So let me just write the formula. I think I was supposed to use the common names or something, because this thing, I feel like I'm wasting time here. Actually, I'm tired. Same thing that you did on when you calculated the moles of here. So here you can also do it by your own. You can do it if you understood what I was explaining there. You can do it. So what do, you just substitute your values. There is 20.4, which is this one, multiplied by the ratio of the coefficients is going to be 1 and 1, and therefore is 40. The answer is 20. My answer here is, let me just verify it. No, the answer is 20.4. I'm tired indeed. Why I want to verify this? Because of 1 divided by 1 is 1. 1 times 1 is 20. 1 times 20.4 is going to be 20 point this. So here what is happening, they say that the one with a less number of moles is a limiting reagent. You understand? The one with a less, so meaning that this one is a limiting reagent. This is a limiting reagent. This is a limiting reagent. Just write it properly for me. Limiting reagent. You must know that. And then from here, since they were asking for what is the maximum mass, so in order for you to get the mass, you will take this limiting reagent. So for the mass, let me use a black. For mass of it was mass of ammonium sulfate. Mass of ammonium sulfate. Therefore, it's easy. You just have to use you just have to use this formula, and therefore it's going to be much easier for you. The number of moles we have them is 20.4 multiplied by the 132, which is the molar mass for ammonium sulfate. You understand? Molar mass for ammonium sulfate. So, and what you have to do, you'll get your mass is 2.69 kg. This is your molar mass. So that was it for today's lesson. You can also remind me of everything that I'm leaving behind, since my duties are so much, understand. So sometimes I do forget that I didn't cover a certain topic. So reminding me is not a problem, you understand. It's not a sin. You're not committing a crime. So you can just remind me. So I guess this video was just helpful for you, and then you can just subscribe to the channel so that you can get the latest notification, and also share these videos. Thank you for watching.